Here we have a number. What number is that? 5 plus 5 plus 25 plus 3. Let's call it n. So the number n in this case is 25. 25 is the same as 5 squared, so let's write it that way. So 5 squared plus 5 plus 5, which is 2 times 5, plus 3. Now, if we do the calculation, 25 plus 10 plus 3, that's the number 38. So n is 38. Now we're looking at this number written as a combination of powers of 5. What powers of 5? Well, I have 5 squared. I have 2 times 5 to the first, and then I have 5. And then I have 3 times 5 to the 0. I can put 3 times 1, which is the same as 3 times 5 to the 0. So my number 38 has been written as 25 plus 2 times 5 plus 3 times 5 to the 0. Now let me indicate that 25, which is 5 squared, there is one of those quantities. So let me put a coefficient here just to tell how many 25s there are. So my number n consists of 1 5 squared, 2 5s to the first, and 3 5 to the zeros. So what we're looking at in here is 5 being expressed, and let me repeat, what we're looking at in here is the number 38 being expressed in base 5. Now, let me write this number n by using some notation. The notation we will use identifies the coefficients of the powers of 5. So there is 1 5 squared. There are 2 5 to the firsts, and there are 3 5 to the zeros. So 1 5 squareds, 2 5 to the firsts, 3 5 to the zeros. Now to indicate that the base involved is 5, I'm going to subscript this concatenation with the number 5. So what number is this? This is the number 38. But we are looking at it in the following manner. 1 5 squareds and 2 5 to the firsts and 3 5 to the zeros. I could also write this number with parentheses and subscript. Both of these are acceptable manners of writing our number 38 in base 5. Based on this example, let's define the general case. What's the general case? I will have a number n greater than 0. I will have a base b greater than 1, all whole numbers. So n will be written in base b if and only if b is a combination of powers of b beginning with b to the 0 up to b to the k for some natural number k. So let's write that down. This is our definition. This is our definition. Let n be a positive integer, b be an integer greater than 1. N written in base b, n is written in base b, or n is expressed in base b, if and only if n is a combination of powers of b beginning with b to the 0 up to b to the k, where k is some natural number. For some k in the set of natural numbers, where the coefficients a0, a1, a2, all the way up to ak are integers from 0 up to b minus 1. So where a0, a1 up to ak are integers that range from 0 up to b minus 1. So every one of the coefficients in our expression have to be non-negative integers that do not equal or exceed the b. Okay. Here is the question that we want to work with. So I want to be able to identify a number that's given and that's expressed in base b. I would like to be able to identify what number is that. So that's our first question. So let's do an example of that. So there is our definition. So let's do an example where I am given a number expressed in a certain base, and I am interested in finding what number is that. example, identify the number let's put 4 2 excuse me, no comments in our notation. 2 0 6 1. Okay, so this number is expressed in base 7 and I want to identify it. Now let's read it and then we'll identify it. What number, how do you read this number? Well, 7 to the 0, 7 to the 1, 7 to the 2, 7 to the 3, 7 to the 4. So those are their coefficients. So there are 4 7 to the 4ths. There are 2 7 to the 3rds. There are 0 7 squareds. There are 6 7 to the 1sts. And there is 1 7 to the 0, or 1 unit. But what number is this? Solution. Compute it out. Do the arithmetic. First, write it in its expanded form. Plus 4 multiplied by 7 to the 4th plus 2 multiplied by 7 to the 3rd plus 0 multiplied by 7 squared plus 6 multiplied by 7 to the 1, which is simply 7, plus 1 times 7 to the 0, which is just 1. Okay, so here we want to use a calculator. So let's do it in a calculator. I'm multiplying 4 by 7 to the power 4. What's the result for that? That's 9,604. So it's 9,604. Plus 2 times 7 to the 3rd, so 2 multiplied by 7 to the power 3, 686, plus, this one's easy, that's just 0, plus 6 times 7, which is 42, plus 1. Okay, so let's finish it up. So I have a 9,604 plus 686 plus 42 plus 1, which is 43. So we're getting 10,333. Alright, so that number, which was expressed in base 7, happens to be the number 10,333. Okay, second question we need to be able to answer. If I am given a number, write it in a specified base. So let's try that type of problem now. Let's do an example of that nature. Alright, so let's use the number 100. Let's write it using base 3 and base 5. Let's do a couple of examples on that. So express a 100 in base 3, base 5. Okay, so solution. Let's try expressing 100 in base 3. Okay, so here's what we're after. We want to write 100 as a combination of powers of 3, beginning with 3 to the 0 up to 3 to the power k, where k is some natural number. Now we're always after the least k necessary. I will explain as we progress in the example. Okay, so first thing to do is let's figure out how many powers of 3 are we going to need. So let's list some powers of 3. So 3 to the 0, 1, 3 to the 1, 3, 3 to the second, 9, 3 to the third, 27, 3 to the fourth, 81, 3 to the 5 is going to be 81 times 3, which is 243. We don't need to use 3 to the 5 in our expansion because 243 has exceeded 100, so its coefficient will have to be 0, but I don't want to write my first coefficient as a 0. So that will be a convention that when we are writing a number in a base, we don't have the first digit as 0 unless you have the number 0. But in our definition, we are not working with 0. Our n is not 0, so we don't want the first digit to be a 0. So 3 to the 5 is not going to be part of our combination of powers of 3, because this coefficient will have to be 0. Okay, so let's see how many 81s can fit into 100. Only one, right? You can say, let's divide 100 by 81. Only one time. 81 goes into 100 one time. 1 times 81 is 81, subtract gives you 19. Okay, so here I have the number 100. Let me call it n. So our number n, which is 100, consists of 181s, which is the same as 1 times 3 to the 4th, plus how many 27s should we use? Well, let's divide 19 by 27. 19 by 27, 0. 27 doesn't go into 19, so 0. There are 0 of them. So plus 0 times 3 to the third plus. So how many 9s? So let's divide 19 by 9. 19 divided by 9. 9 times 2 is 18, so there are 2 of those. 2 times 9 is 18. The remainder is 1. So there are 2 9s in here. So it's 2 is 3 squared. Plus, now how many 3s are in 1? 0 of them. There are no 3s in 1. So plus 0, 3 to the first, plus, and then finally 3 to the 0, which is 1. How many times does 1 go into 1? Well, 1 time. So I'll say 1 times 3 to the 0. Okay, so the number 100 expressed in base 3 is going to be 1, 3 to the 4th, and 0, 3 to the thirds, and 2, 3 squareds, and 0, 3 to the firsts, and 1, 3 to the zeros. Using our notation for base 3, we'll subscript the 3, and we write all the coefficients that were found for 3 to the fourth, 3 to the third, 3 to the second, 3 to the first, 3 to the 0. Let me make sure I write them all. Okay, so 1, 0, 2, 0, 1, and I have to remember that this is written in base 3. Okay, next one. I want to express 100 in base 5. So how can I express 100 as a combination of powers of 5, beginning with 5 to the 0, 5 to the first, 5 squared, and so on? Let's first find some powers of 5 to see how far we need to go. So 5 to the 0 is 1, 5 to the first is 5, 5 to the second is 25, 5 to the third is not going to happen. I'm not going to get 5 to the third in my combination because 5 to the third exceeds 100. So my combination is going to consist of 5 to the 2's, 5 to the 1's, 5 to the 0's. So n, which is 100, right, is going to be, well, it's going to be 4 of those for sure. 4, 5 to the 2's. That means there got to be zeros of everything else. How do you write that? Using base 5 notation. Well, the coefficients are 4, 0, 0. All right. That is going to be all for now.